exit, but please do have a seat and enjoy the festivities. So as is tradition, I'd like to start off with a nice slideshow of pictures reminding us of all the wonderful activities that we've gone through and seen as a department for last year. I think as all the photographs are a testament to this community, this is the place to do physics. the science that's done at Cal continues to win awards, continues to motivate people, continues to stir our imagination as to what the physical world is really about. And every time I write this talk, it's amazing to look at all the different activities that span physics at the scale of subatomic particles, physics at the scale of accelerators, physics that goes beyond basement labs to national labs to international collaborations, then also out into space. So I wanted to share a few vignettes that you can read more about on our news site and also in the magazine about some of the interesting science that's happening at Cal. So there continues to be this search for matter that doesn't want to show itself. And we sort of give it this name, dark matter. And in this search, there are the heavyweights, even though they're called WIMPs. And then there are the lightweights, even though they have this name, axion, which gives you a bit of strength. But Professor McKinsey says we should be looking in the Goldilocks spot, something that's lighter than our heavyweight WIMP. And in fact, the collaboration is now bringing the power of superconducting transition edge sensors, which I must say is the longest acronym I've ever seen. But the TES part is the transition edge sensor part of it. And they're going to look in a place where no one's ever looked before for this dark matter. And they're going to look with detectors that are so sensitive, single vibrations of the lattice at 8 millidegrees Kelvin can be a problem. And this particular team is well set for doing this, pushing the sensitivity 30x beyond anything else that's out there. So we wish them good luck in this search for dark matter. Hopefully someone will give a talk and say that we have found this dark matter. I don't know, maybe you change the name next time. And then we move further from matter that doesn't show itself to matter that shows itself only in a very flat sheet of graphene. And this is a great title, Janus Graphene. So Janus is this Roman god that you've seen on doorways and coins that has, two faces looking inward and outward, so on and so forth. And it did take me a few minutes, I got to say, I had to go read the Nature paper to figure out why this graphene is Janus in this particular case. But if you look at it, it's very interesting. It's all about the edges. So you see this edge has a particular topology, this edge is different, so on and so forth. So it turns out Steve Louie and colleagues have shown that if you make these two-dimensional materials, and ribbon-like materials, right, that have different edge states, you have different properties, and in particular, different magnetic properties. In some cases, you can get a nice chain, of spin objects, which could be qubits. In other cases, you can actually transport ferromagnetic current without using extra magnetic fields or other coercion that may be needed to do that. Did I get it right, Professor Louie? Thank you. Well, what if you want to go beyond graphene and look at the physics of crystals? So this is a nice article in Nature Physics coming out from Naomi Ginsburg's group. And the question at hand is if you have individual particles or nanoparticles, how do you turn them into a crystal? And the brute force method would be, well, you just put a lot of them in a spot and they condense. And it turns out there are more efficient ways than brute force methods of doing this. And in particular, you can coerce them by having different ionic channels to guide them. And what they figured out was this very nice phase diagram of how you go from a colloid to a superlattice. And the idea is that, in fact, it may be much more efficient to go through a liquid phase. Once you go through a liquid phase, there's strong interactions, you can anneal out all the defects, and you can control that speed using these ionic channels. So this is a very beautiful paper about how stuff comes together, right, at some very nanoscale. So I'm moving up now from matter that I could not see, matter that was two-dimensional, to some matter that's now in a crystal. And then one thinks about, well, what are new structures that we can make if we're thinking about two-dimensional materials? This is the superconducting ode to that. In this particular work, scientists took Josephson junctions, and in particular arrays of junctions, and removed the substrate from underneath. So they were flying, like little ribbons. So this is a flying quasi-nano ribbon that's there. And the idea with this structure is that you can access quantum regimes because you don't have that capacitance to resonate with, that in fact may be topological. So you can access a new category of phenomenon that go beyond Cooper pairing. So Cooper pairs are two quasi-particles or electrons that come together, right, and form a unit. These particular devices now have pairs of Cooper pairs. So they have 4e periodicity in their devices. And the same with their fluxons. And the idea for that is this is a way perhaps to have topological qubits, but also be able to put your finger on them. Because sometimes with the Majorana qubits, I forget where I put my last Majorana qubit. Okay. And then those fingers, those wires are particularly important In this entire endeavor, if you like, of quantum information science or quantum computing, one tries to put the information capacity of the universe on a small chip, right? And then it's cynical experimentalists like me that ask the question, well, that's great. How do I get the information off the chip? My fingers are not quantum. So in fact, there's a strong marriage, if you like, or intersection between the engineering disciplines that are focused on efficient ways to move quantum information around. And this year that has gone by has marked a great partnership between Y Quantum, Switzerland-based company, that's looking exactly at that problem. How to make very efficient multiplexers and technologies that work at cryogenic temperatures and at microwave frequencies. So this is a different slice, if you like, of the Berkeley environment going in the engineering domain. Okay? And then I'm sort of zooming out a little bit more, saying that, well, this is all very good and possible and very exciting unless we get hit by an asteroid and all die. So this particular team of, thank God the undergraduates are going to save us from this. Right? You are the future, maybe even today. So this particular group was in a ULab setting. So ULab is a wonderful program here at Berkeley where undergraduates get together and for a semester look at a particular scientific problem. And this team looked at how can we analyze in the world of large astronomical data and find and pinpoint those asteroids that may smash into us and cause us to die. And I apologize for the crude remarks, but that's the best I can do as a quantum physicist when talking about asteroids. So they took this data that had 300,000, I think, streak candidates, and they used machine learning methods, right, to get down to 30,000 and to 30. And then they identified one with other observations that is a real candidate, and it was bona fide by other agencies, and it's been called Asteroid 2025 FD. So those calculations are made. You should rest assured this particular one will be 880,000 miles away from the Earth. We should survive, but I think it raises the very interesting question of what are efficient ways to use the human mind to use data that's collected by mechanical means. And sometimes the human mind certainly does a very good job at finding such patterns. Okay. This is science that's done perhaps in centers, in smaller laboratories, but one of the hallmarks of Berkeley physics are very large centers that intersect science at all scales. There is the vibrant N3AS Center, and we're very happy to report it's moving forward, right, into its next phase. And in particular, this center is looking at multi-messenger astrophysics, focusing on fundamental symmetries, nucleosynthesis, dark matter, dense matter, astrophysical simulations. And in fact, in a few weeks, we will have and enjoy the visit of a high-level contingent from CNRS, and we welcome them into this particular center. There is, of course, physics that's done, again, in a different aspect by Barbara Yatsek and others, and a large team that's there, looking at the physics of the electron-ion collider, the EIC. And they ask the fundamental questions: how does the mass of protons and neutrons arise from nearly massless quarks and gluons? How do you make something from nothing? This is basically what you're asking. Very good. How does the spin of the nucleon arise? It's hard enough to teach it. I don't know where it comes from. That's beyond my pay grade, Barbara. Okay. And what are the emergent properties of dense systems of gluons? Okay. Then we have physicists that are thinking about similar questions and even beyond to the most fundamental edges of the universe in the Berkeley Center for Theoretical Physics, thinking about particle theory, particle cosmology, string theory, and everything that comes under the theory of the universe. And they would like to further our understanding of said universe that we live in. In the quantum domain, there are two centers that I want to highlight. One is the NSF Center, the CIQC, which asks, again, those fundamental types of questions about quantum information. How do we capture it with entanglement? How do we encode it? How do we manipulate it? What are the algorithms? What are the, in fact, uses of this new resource that's coming up? Okay. So these are the types of questions, basic science questions that CIQC is asking. And then there is also the Advanced Quantum Testbed that looks at the other side of the question. Well, how do you build this entanglement? How do you manipulate it? And it's a co-design process. If I have a machine, what is it good for? And the previous slide was, well, here's the machine you should build for the algorithm that we want. And this back and forth is rather critical to quantum information technology at this moment. Okay. Then we have things that are centers of centers, if you like. Right? So this element is now coming into being, hopefully, in this year of quantum, 2025. The quantum nexus, where there's the intersection of these various subcenters, theorists, experimentalists, folks that are working in industry, folks that are thinking about engineering applications of quantum, all coming in one spot, which was a Masonic temple. Okay. I kid you not. So it is a beautiful space right on the corner of Bancroft and Shattuck, right? That's there. 7,000 square feet, and hopefully this number, which is in flux, will be large, with a large room capacity so we can go in and hold events, and in fact have seating there for these other elements in the ecosystem that we'd like to intersect with, and we'd like our students and faculty to intersect with. Okay. So the other critical piece of this, which is what I showed in the slideshow, it's about all the people that go in this. And there are many programs that bring in students, faculty, postdocs from all over the world. And they're really the cornerstone of Berkeley physics. So here's a abridged list of some of the programs we run for our international students, students that in fact are in different parts of the campus, okay? Students that are thinking about at the undergraduate level how to conduct a research project, in particular with this Pi² program. And we're happy to report, and we're very thankful to Paul Richards, who's a faculty member beloved in our department, and also his family, who has left behind this beautiful gift of the Innovation Lab for undergraduates, which will have a formal opening very soon, and I believe the date is October the 10th. And this gives a space for undergraduates to access state-of-the-art equipment for any of their prototyping needs. And in particular, what's coming up beyond the 3D printing and laser cutters and mechanical things that were there, there's now an optical table that's been installed in the Physics Innovators Lab. Okay. And in fact, the vibrancy of this undergraduate research was very palpable at our research fair this year in 2025, where in fact, I believe the location now is in Pauley Ballroom. It's a nice big space, giving us an idea of how large this effort is and how vibrant it is. And it's co-sponsored by a wonderful program called the MPS Scholars Program, which you may know something about and will be mentioned a little bit later. Hold on. Okay. And in particular, this event now is in collaboration with Astronomy, Math, EPS, and all the MPS elements. Community. Berkeley functions because we are really a family of different elements all stitched together, whether it be students, scholars, administrators, and faculty, and I'd like to highlight some of those members of our community. The Miller Institute plays a critical role in bringing together visitors both at the postdoctoral level and the professorial level. In this particular case, we have two of our own who have been elevated to Miller professors so they can just think and move biosciences forward or biophysics forward. So we'd like to congratulate Professor Hernan Garcia and Professor Naji, who are Miller professors. Visiting professors that have been coming and will continue to come through our halls include Professor Marina Philipp from Oxford, Professor Vidya Madhavan, University of Illinois Urbana-Champaign, and Professor Nicholas Spalding from ETH Zurich. And we have our two Miller Fellows, Dr. Zhengjiao Zhang, one Miller Fellow from Zhengjiao Zhang from Princeton University. Okay. Faculty awards. So first of all, I must apologize. If you have won an award and we have not put it here, it's all on us. We have missed it. There are a lot of you that win awards. Please accept my congratulations if you're not on this list. If you're on this list, accept my secondary congratulations now. Starting with Stuart Bale, who has won the Arctowski Medal. Raul Bresenio, who is a Sloan Fellow and he's also won the PCASE Award. Michael Cromie and Steve Kahn have been elected to the National Academy of Sciences. Congratulations. Ken Bullock, the American Association for the Advancement of Science. Rafaela Margutti, again, the PCASE Award. Hitoshi Moriyama, the 2025 Particle Physics Medal. Gabriel Ribigon, the Heising-Simons Faculty Fellowship. Bernard Sadulay, American Association for the Advancement of Science. And Dan Stamperkern, the Senior BEC Award. Okay. Now, I would like to move on to a very special award. This is one of the highest honors that Berkeley gives out to its faculty. This is the Berkeley Citation, and this year it is truly a pleasure to mention and to introduce Frances Hellman, who has left a deep and enduring mark at UC Berkeley and the world with her dedication to education, leadership, and public service. This is an award that the central leadership gives, and it is at this time that I'd like to invite Dean Kahn to go ahead and make the presentation of the award.
For those of you who are unaware of the Berkeley Citation, it is one of the highest awards that is given on the Berkeley campus. It's awarded to a variety of distinguished individuals or organizations, academic or non-academic, whose contributions to UC Berkeley go beyond the call of duty and whose achievements exceed the standards of excellence in the fields. The Chancellor works closely with an advisory committee to confidentially select each recipient. I can't think of a better candidate for this award than Frances Hellman. Frances has worked tirelessly to strengthen academic institutions, promote diversity, nurture future scientists, and foster deeper public understanding and appreciation of science. Her contributions have left an enduring mark both within and beyond UC Berkeley. Hellman's leadership on campus began with her role as chair of the physics department from 2007 to 2013. I remember that period because I came and gave a colloquium then, which Frances introduced. Following her role as chair, Hellman was appointed Dean of Mathematical and Physical Sciences, a position she held from 2015 to 2021. As dean, she supported what were then 5 departments, now 4 departments, by developing and executing a strategic plan to recruit faculty, ensure world-leading research, support student success, and promote diversity. Her work led, as Irfan already mentioned, to the creation of the MPS Scholars Program, for which she served as principal investigator. This is a multi-million-dollar initiative funded by the Moore Foundation that provides critical support to underrepresented undergraduate students, dovetailing with successful efforts to raise funds to support and increase undergraduate research experiences. Frances's service extends far beyond the university. From 2020 to 2023, she served in the presidential line of the American Physical Society, taking on the roles of vice president, president-elect, president, and past president. In all of these administrative activities, she's been guided by the principle of leaving ego at the door. Her goal was and is to empower others in the organization to succeed. She believes that leadership requires balancing a high-level strategic view with an ability to directly engage in hands-on problem solving when needed. And let me just say that in addition to all of this, Frances is also an outstanding scientist who's made fundamental contributions to condensed matter physics and was a key member of the LIGO collaboration that led to the first detection of gravitational waves. So congratulations, Frances, and can you please come up?
We're all really proud of you, Frances. It's great to have you in the department. This year, we also had and enjoyed some new staff members in the department. And one of the things I like to do is ask them about themselves, about their bio, what are their aspirations, where do they want to go, and also share quotes that they find inspirational. So welcome to Sheila Javeri, who's a financial analyst. And she shared the following quote from Stephen Pressfield. "Creative work is a gift to the world and every being in it. Don't cheat us of your contribution. Give us what you've got." So welcome, Sheila. Kate Fryermuth is now joining the team in curricular planning. And she shared a classic quote from Mahatma Gandhi, which was, "Be the change that you wish to see in this world." Okay. We will hold you to that, Kate. So, welcome. Welcome to the department. Okay, Roberto. So Roberto was here, student. There he is. President of SPS, right? And I don't know how many quantum demos we did over the years. And now he's taking on an even grander role, right, as being really in charge and the lead of this instructional demo division. And he shared with us this Pablo Neruda quote, right? "Mi deber es vivir, morir y viver." So my duty is to live, to die, and to live. Now, Pablo, of course, is a very famous poet, and in particular has an interesting history in this Pinochet era of Chile that's there. So the rough translation is, my duty is to live, to die, to live. So I don't know which stage you're on. I would imagine it's the first living stage. And hopefully that last living stage is what you're working on. Well, So congratulations in the new role. Okay. Por nada. Stephen Irons, welcome. Okay. Stephen is joining us from Yale University, and I think I just missed him because I left in 2000, a few years after that. Although, Dan, I imagine you've overlapped a lot. So it's a tremendous pleasure to have him as Director of Instructional Services. And he shared, millions saw the apple fall, but Newton asked why. I think the South Asian, we just ate the apple. But nonetheless, fantastic. Welcome, Stephen. And of course, Kayla Gordon, who is joining us as our AP Analyst and Executive Assistant to the Department Chair. And she shares, again, on this theme of sharing quotes from poets from Maya Angelou. If you're always trying to be normal, you will never know how amazing you can be. Wonderful quote. And I have no doubt Kayla will be amazing. Welcome to her. Okay. Many of our staff members have won SPOT awards. These awards are given for excellence in collaborative activities, the proficiency in accomplishing goals, promoting inclusion and belonging, innovation in their jobs, and mastery of the things that they do. So again, congratulations to Claire Lega, Sheila Javeri, Elizabeth Nakahama Ryan, Harneet Gill, Mavis Julao, Kathleen Cooney, John Deasy, Ariana Castro, Kathy Gwen, Stephen Pride-Rafael, and Marjani Jones. Maybe let's have some applause for our award winners. And we have our new crop of achievers coming here, and they span several view graphs, of course. So first of all, we'd like to welcome all our graduate student class. I will spare you reading all their names, okay? But please do get to know them and get to know each other as the year goes forward, okay? Some statistics. Last year, there were 1,457 applications. All the faculty know because we read them, right? And there were 44 acceptances to that number. So tremendous interest in our department. 6 major fields of physics, applicants from along the globe. So just as a breakdown, because we love this data science, we can't get enough of it. Of that particular number, 781 individuals expressed an interest in experiment. 676 have not figured out yet that this is the thing to do. So I'm sorry, it's chair's prerogative. Okay? And you can see these are the fields that they came in with, and we welcome all of them. Sometimes I feel like a theorist also. It's okay. Moreover, that's just the tip of the iceberg. In addition to our graduate students, we have a vibrant community of postdocs. So again, hopefully you'll intersect with them and welcome them into the department. They do span 2 view graphs, so they are there. Welcome to the department. And of course, this is an opportune time to reiterate the values that we hold dear to us as a community. And in fact, codifying these values, having activities to remind each other of these values, and in particular, to move forward and say, what do these values look like in any given environment, is something that all of us feel very strongly upon, and many of the folks sitting here, in fact, champion. We are thankful to you for that. And in particular, I would like to use this moment to also share this very personal thought from all of us. We are living, no doubt, in very unprecedented times. Okay? But rest assured that it is the prerogative of this department, its staff, its faculty to support you in your success in any way that we can. So you are top of mind. You are right in front of our thoughts. And the trajectory forward is the discussion of many, many conversations, day in and day out. And I know sometimes it's difficult because there are things given the particular environment that we're in that we can share with you at any given time or cannot. And we hope to navigate those things in the best way forward for all of us. But do rest assured, you are part of the family and you are very much in our thoughts and minds. And I don't know how much more I can say with that to console you, but hopefully you get the sense that we are all here with you. Okay? In particular, you may see these cards posted in various places in the department. Do take a moment to read them and remind yourself of the various principles that we continue to evolve. Okay? Along with that, we have, of course, various organizations that add richness to our fabric of Berkeley physics. These are student clubs in various disciplines and various directions. Some of them are listed here. So again, do go to their activities, whether it's barbecues or study halls or the guest speakers that they invite. Enjoy the richness that is part of this vibrant community. Okay. Speaking of the undergraduates, okay, some statistics from 24-25, 369 majors, about 400 intended majors, 192 transfer students, half of them continuing this wonderful thing we call education. The other half trying to either, well, this one is working, I think they may employ this one. So that's basically the 2 halves that are left, so we wish them well in that journey forward. Okay? And then, of course, there is this sad part of the talk where this particular year, we lost so many of those that we held dear in this department. This was a particularly sad year for us. So what I would like to do at the moment is there are some slides that share the memory of our colleagues. I can't do justice to them and by any chance read them. So I'm just going to flash them and we'll just have a moment of silence as we go through each one of these particular colleagues. So please do read the slides as they come up. During the year, we will have various events and symposia to honor our colleagues, starting with next week. We're thankful to Chris McKee for setting up the first colloquium of the Physics Colloquium series in the fall, next Monday, where we will have individual speakers talking about the various faculty members. So I do encourage everyone to come and so that we can honor our colleagues that way. Beyond those particular events, there are a few other important things to mention. So 2025 SIGGRAE lecture is coming up, and we're thrilled to have Fabiana Giannotti with us. She is an experimental particle physicist, best known for her leadership of the team that discovered the Higgs boson at CERN, and she is currently Director General of CERN. So she will be here. It'll be wonderful to have her visit. Okay. There is an initiative which our Dean Kahn has really been spearheading. The idea is to build a quantum California. We were giving you sort of little vignettes of the intersections between engineering disciplines and physicists and national lab members, et cetera. This is all now coming together also with state support. There's a picture of some of us visiting the state legislature. And in fact, this has gained a lot of traction, right, where the state is now heavily interested in quantum technologies and the future of California with respect to quantum technologies. And there will be a very large kickoff event, right, in November, so stay tuned for more information on that. Okay. I'm also happy to report that our supporters are vibrant and strong, both in their moral support and also their financial support. So I'm happy to report there is a multi-million-dollar gift from the Lineweber Foundation to establish a new center for theoretical physics at UC Berkeley. This deserves very much a round of applause. The new Lineweber Institute for Theoretical Physics will include new postdoctoral physics fellows, funding for graduate students, and convenings with other institutes that are also benefited from gifts from the Lineweber Foundation. So we are all very excited about this intersection of theoretical science, which in fact goes across multiple fields and disciplines, and we very much look forward to that coming together in the coming year. I would also like to mention the nuts and bolts of the operation, quite literally here. So the machine shop has been here forever and is truly an invaluable resource. And one of the tasks that I wanted to pursue for some time is to figure out a way to keep it vibrant and viable. So on a later time, we can talk about that. But at the moment, we need users. We need people to come in with drawings and go use this shop. So use this opportunity to go draw something and give it to our shop folks. They can do really amazing things. They have this wire electron discharge machine. Of course, if you want to make really perfectly square corners in something, every once in a while you can do that, and they can do it really well. So I promise to put this slide in here as well so that we can show our support, both in terms of structure and, of course, of usage of this unique resource. Okay. Coming also in the upcoming year, we have finished our decadal review, right? And we've gotten comments and feedback, which we've shared with the community. We'd like to start the process of getting together and getting the community together to think about ideas of how to change policy moving forward. And in particular, we'd like to invite back Britt Andriotta, who many of you may have intersected with during her last visit. She was the former Associate Dean of Students at UCSB and has tremendous amount of knowledge in facilitating such discussions. So that's coming up soon. At the moment, I think the target date is a little bit in January, but getting all the schedules together is something we're working on. So do look forward to that. Okay. And of course, I'd like to pay homage to our leadership team for this semester and this year. We have Professor Dan McKinsey, who will serve as Vice Chair for Faculty Affairs, Professors Yuri Kolomensky and Heather Gray, who will co-chair instruction. Okay. And Professor Shimon Kolkowitz, who will serve as Vice Chair for Faculty Appointments. So thank you to our leadership team. And our head advisors, Professor Gabriel Uribigan will be the head undergraduate advisor, Professor Dan Kazin will be the head graduate advisor, Professor Holger Mueller will be the head GSI advisor. So with that, I want to give thanks to all the folks that make this department work. They are sitting in various corners. Some of them don't want to be mentioned. They said, don't mention me by name, so I will stick to that, but we appreciate you. And moreover, this is the third time I'm giving this tea, so that reminds me that will be the last time because it will be my last year as chair. So I owe you many thanks for all the support that you've given over the years that have gone by. And moreover, I wish you a very good year going forward. So with that, thank you and enjoy the refreshments outside.